Good afternoon, everyone. I'm Amaury Leroux, Marketing Manager at Edouard Cybersecurity. Thank you all for attending this webinar. We are very happy to welcome you for this presentation, and we hope it will meet your expectations. Welcome to this webinar entitled, What are the main DevSecOps challenges and how to overcome them? You will be joined by Edouard Viot, VP Product and Engineering, and Soujanya, Product Marketing Manager at Edouard Cybersecurity. This session is recorded. You will receive a link to the replay of this session during the day. For the fluidity of this webinar, we propose you to answer all your questions at the end of the presentation. You can ask them throughout the webinar in the chat lab. Now I just have to leave the hand to Soujanya, who will start the presentation. Have a great webinar.
Thank you so much, Amaury. Hello, everyone. Let us look at the agenda for today's webinar. First, we will discuss why DevSecOps is important for organizations. Then we will look at a few statistics from the Agora survey that was conducted earlier this year. And we will discuss the main initiatives of DevOps and DevSecOps teams that were identified in this survey. Then we will show you how to check your DevSecOps maturity and prioritize your activities when using such DevSecOps strategies in your teams. Then we will introduce you to a cloud-native application protection solution that could help you overcome the challenges we discuss. And Edouard will give you a demonstration on how to automate your false positive management and reduce the false positive rate in the production environment. Please feel free to ask your questions, and like Amaury said, we will answer them at the end of the session. So let's get started. Earlier this year, we asked CISOs from different public and private organizations if they think that their DevOps process is secure today. And when we analyzed the results, we saw that 65% organizations are either unsure or lack security in their DevOps pipeline. This security element is missing from such DevOps teams due to several reasons. For example, the cultural resistance. The developer, security, and operations teams are working independently from each other. And this in turn leads to the fact that a small change needs a long time to be implemented, and the overall release process gets delayed. There also lies a challenge in the integration of the right tools, because today there are plenty of tools in the market, and you need to find the tool that fits into your strategy and that seamlessly integrates into your existing pipeline with the other CICD tools. It's not really an easy task. Then there is the knowledge gap, because developers have to be trained in secure coding practices so that they can collaborate more smoothly with the other teams and be associated with more security-related tasks other than their daily activities. It's really important in order to inculcate a DevSecOps philosophy within the team. And finally, we see that in a DevOps environment, the focus is more on application delivery than on development itself, due to which in the process of rolling out features more frequently, the application security gets ignored. And this could be dangerous, because if the security is ignored, at the end of the day, your applications will not be able to deliver a successful customer experience. So it's really important that companies overcome these challenges and adopt a DevSecOps model, because this model in turn, with the right tools and right culture, will be able to accelerate your digital transformation within the organization. Now, when we talk about DevSecOps, it means adding security to the evolving process. And the automation of this security in your CI/CD pipeline is really at the heart of DevSecOps. So today, when the developer needs to push a code change, he has to create a new build and then run automated tests in the pipeline to validate it, and then release it and deploy it automatically to the production environment. And it's really important that all these stages are automated in order for you to have a successful and modern software factory. And there are several benefits to it as well, because you can find vulnerabilities much earlier in your life cycle, and the costs to correct them will also be significantly reduced. And you can iterate faster by accelerating the feedback loop with your customers, and thus overall you will be able to release more often. So automation is really the key here. Then we see that companies today, they are adopting a microservice-based architecture instead of writing a monolith of code, as opposed to what they used to do traditionally. And they are using containers in order to run these microservice-based applications, because it's easier to cut them up into services that speak to each other. It's easier to deploy, scale, and manage. In fact, Gartner also projects that around 90% of global organizations will be running containerized applications in production by the year 2026. So it's not just the trend of today, but also the trend of tomorrow. Now, in terms of popular technologies, we see that when companies speak of containers, they use Docker, and they use Kubernetes to manage all their containerized microservices and applications. It's really the standard for container orchestration today. We also hear about serverless applications very often, and to be honest, they are really good for automating some of the repetitive tasks and increasing productivity. They let you write code in AWS, Azure, GCP, and run it in response to a trigger without having to worry about VMs or containers or scaling. But to be honest, it's adapted for specific and precise use cases and not for everyday use. So among our survey respondents, we saw relatively lower interest in serverless applications. Now, we also asked companies what, according to them, are the top initiatives that a DevSecOps team needs to perform best. And these were the top 3 initiatives. First is the usage of containerized technology, because like we just said, containers package everything that is needed to run the application, and it allows the application to be easily managed, deployed anywhere you want, and rapidly scaled. And moreover, it's better if you use a container-based security solution in order to protect your containerized application from within the containerized environment, instead of trying to protect it from outside the environment with some classical and traditional application security tools. Then the integration of security right in the build phase is also a very important factor for shifting left. And if you don't do this, basically you are delivering an insecure application in the end. So it's really important. And then lies the collaboration between the different teams. So a major cultural change is required. The development, security, and operations teams need to remove their silos, and they need to work more closely together, understanding each other's constraints, and with a shared responsibility for security, with the shared goal of delivering a secure application. And they need a security solution that would help them that would support this kind of collaboration between the different cross-functional departments. So now that we have an overview about DevSecOps, let's see how we could check our DevSecOps maturity. We looked at the OWASP DevSecOps maturity model that exists today already in the market. And we also discussed with many of our customers and prospects and made some observations about their challenges. And we built this DevSecOps maturity survey in order to provide a structured way to evaluate, measure, and prioritize your activities on this journey. And this survey could be taken by anybody who wants to enhance their security within the organization. So it could be taken by the technical upper management, like the chief technical officer, the chief information security officer. It could be taken by the API developer, the cloud architect, the site reliability engineer, and so on. We ask you some questions in this survey to evaluate you on the following 6 dimensions, like build and deployment, culture and organization, patch management, application security, monitoring and logging, test and verification. And for each question, we ask you some options. For example, where does your team stand today? That is your actual or current level. And after that, we also give you some options so that you can tell us where does your team want to be? So your desired level. And based on the responses that you give us, we give you your maturity level along with some helpful recommendations in order to tell you how to close the gap between your actual and your desired maturity level. And these recommendations are really tactical, to be honest, and something that you can implement immediately. For example, if the question is, how secure is your application today? Then we tell you that, and if you say that today your application is protected against the attacks listed on the OWASP top 10, and you want that in future to protect the east-west traffic between the containers of your application and the APIs of your microservices, then we tell you that you need to ask your developer for more precise information on the security to describe your API and application, like in an open API file. So the recommendations are going to be helpful, we hope. And once you fill the survey, you get a visual like this, like a spider chart with all the different dimensions and your corresponding actual and desired maturity level indicated on it. And below the chart, you will be able to see some recommendations on the web page. The maturity, there are 4 maturity levels. Level 1 being the basic understanding of security practices, and level 4 being advanced deployment of security practices at scale. And today, if you have a low maturity level, you really don't need to be disheartened, because it's a journey and we are there to help you to reach your desired state and to help you advance in the DevSecOps realm step by step, incrementally. So we recommend that you take the survey and find out your DevSecOps maturity today. Now that we have an overview on DevSecOps and also on how to check your DevSecOps maturity, we want to introduce you to a cloud-native application protection solution in order to help you overcome the challenges that have been discussed so far. This solution, called Trusted Application Factory, is based on our leading web application firewall technology, and it has our security engines running in a container very close to the application. So it really conforms to the security as code era and the zero trust security model, because here we put the security as close as possible to the application. And it's easy to scale with the load of the application, keeping the security aligned at all times with the application version and up to date. And also it will help you reduce false positive rate in production by detecting them much earlier in the pre-production environment. And the form factor is such that it will support high availability and performance of your applications at all times. The footprint is lightweight, and the best part is you will be able to integrate application security in your DevOps pipeline seamlessly and without compromising your DevOps speed. Edouard will tell you more about this security solution.
Thank you, Soujanya. So yeah, in order to do so with Trusted Application Factory and what Soujanya has already explained, we created a really simple model in order to ask information to the API developer in order to enforce them close to the application. So an example is the open API file that we can take it. The developer is used to create this kind of file. We can take it, inject it to our containerized technology, and then to protect the API. And we can be deployed close to the API and in different pods in a Kubernetes cluster, following the API when the API will scale, for example. So this is a good model, leveraging some information from the developer to do a better level of security. But of course, it also combines all our security engines in order to detect vulnerability exploitation, for example, from the OWASP top 10 that we cover. And then the combination with OpenAPI plus our security technologies permits to bring an advanced API protection level. Of course, we are speaking about API because it's more and more important inside the organization, but we can do the same kind of protection for classical websites. Another thing, the solution has been synced for collaboration inside your organization. means that depending on the company, the organization will not be the same, and it's really important for the different teams inside the same company to be able to collaborate through this solution and to exchange information and so on and so forth. So as a solution, we created something where, for example, transversal security team will be able to design a classical or general security policy and then ask some qualitative information from other teams, for example, the DevSecOps teams. But it's really up to you, and we can adapt to your specific needs and use cases and to different organizational model. But yeah, we really created the solution with the governance in mind and being able to validate some things that the DevSecOps could produce and so on. So in order to explain what we really do inside the different step of the CI/CD pipeline, so the first step is when a developer provides some code, a new version, an update of a code, he could also design the security with our security solution. So we leverage existing technology. We didn't want to reinvent the wheel, and we really wanted to leverage what the developers already know. So let's say YAML file configuration with a simple configuration file, you can give some information that will be enforced after. So the context of the application is my backend running on Linux or Windows, is the language, the programming language used is PHP or Java. Do I leverage a SQL database, for example? All these questions could be answered, and we will automatically adapt our security strategies thanks to this qualitative information. OpenAPI, like I said, we can enforce some information that we can find inside the CI pipeline, and we also created the workflow as code technology. So workflow as code is a way by writing some Golang code to directly describe your security policy and to do some tests, some loop, and so on. It's for mature customers, but we really created a new standard and a new technology in order to do really sophisticated use cases. So once you have written, for example, your configuration or even your Golang configuration in order to explain what you want in terms of security policy, in the CI/CD pipeline, before putting in production, you may have a pre-production environment and test your application before putting it in production. So here you can integrate Trusted Application Factory for several reasons, in fact. The first one is if you test some vulnerabilities, let's say with Dust technology, for example, you will be able to test it with and without Trusted Application Factory to know your real risk and the residual risk once you have our protection. And then the other main interest to put our solution in the test environment is to be able to detect false positive before you put it in production. And we will see it inside the demo just after, but the aims of our solution is to detect this potential problem and to automatically generate some configuration file in order to solve the problem. So another aims of the solution is really to solve the false positive before we put in production, where in a traditional model, we would have to put the application in production and then test if there are some new false positive. Then when we will release the application, we will transform all this qualitative information into security policies. We will do an aggregation and then put them inside the containers that will protect the application. Then the containers will be launched, that are fully scalable, where we will, in the run phase block or the attacks, provide scalability when needed. And then we will create some logs in order to tell what attacks have been blocked, but also to give other information to the security guys. So let's do the demonstration. So we have made a demonstration inside the GitLab CI environment in order to give a real example. So my first script is the YAML file of the CI. So it's not part of Trusted Application Factory, but it's what will be run when I will execute my CICD pipeline. So here I have an example of an API that I just created. Then I will put Trusted Application Factory in order to protect this API. I will inject some configuration in it. Then I will launch my API, and then I will put some QA tests on the application. Some QA tests that may make sure that the application is working well. And then I will ask Trusted Application Factory to show me the logs and to also to tell me if there are some false positives, for example, to give me some hints on how to block them. So this was the configuration on the CI part. Then the configuration of Trusted Application Factory. So this one is a general file saying, okay, I will protect this backend and then redirect the traffic to this backend. I have a small file for my execute my false positive exception file. And then the QA test that I will run to make sure I can create my new application. And in the last test, we put some HTML injection inside the query to show you an example of false positive. So here I see when I build that my test failed. So I will look at the logs. And looking at the logs, I see that everything is being created. It's okay. I have my API, my security solution. I can inject my YAML file. These first 3 tests are okay, but the last one is not working well, and it blocks the process of creating my application. So since I asked how to solve the issue, Trusted Application Factory generated the code that will be able to handle this exception. So here I will copy paste for the demo. So I take my exception YAML file, I will edit it and add a new rule in order to prevent this issue. And if I run again this environment, I will be able to solve the problem and to have my application built. And I have solved my false positive issues that the new version of my application occurred. So what should the DevSecOps team perform? So we asked the market and so on. Some answers were about the scaling, the measurement of metrics, CICD pipeline integration, the faster time to market. But the 3 most important was having a containerized technology to follow the same rules on the application and to have the same maturity model, and then the integration of the security right in the build process. And the collaboration between the teams are the really important subject for our customers, since they are really in the process of transforming into a DevSecOps organization, and security tools must adapt to their own context. So what you have seen today is Trusted Application Factory that has been made to answer to all these pain points from the customers. And thanks to the feedback that our customers and prospects have made, we created a security solution tailored to their needs. So we have a whole portfolio of security solution to protect the application. So we have the web application firewall that you could deploy it on-premise, both with bare metal appliances, but also with VMs. It's also integrated into the cloud marketplaces like AWS, GCP, or Azure. Then you have a Cloud Protector. Then with Cloud Protector, it's a full SaaS protection. So it means that from your DNS, you redirect your traffic to our infrastructure, and then if we don't block the request, we will let it pass through your backends. And then this new product, which is named Trusted Application Factory. And so this is another form factor made to protect cloud native applications. So we will answer to the question. If you have some any other question, please enter it into GoToWebinar so that we could answer them.
Thank you, Edouard. So we have the first question. Can you give me the pricing model?
Yeah. Do you want to take it, or do you want me to answer?
Go ahead.
Okay. So for the pricing, we have a subscription model. So it means that we have two ways to price the product: the number of application or APIs that you want to protect, but also the number of requests that this application will do. So with these two information, we will be able to decide of a price. And we can have two different models. So a kind of pay-as-you-go model, where you will be billed for what you really use. Or if you prefer to pay annually, for example, we can create some credits, a credit system that will work like the pay-as-you-go model, but you take some credit first, and then once you will use them, it will decrease your number of credits.
Thank you, Edouard. Could we deploy it as a gateway protection?
Yeah. So different deployments are being made, in fact. In this slide, we have shown a model that's where Trusted Application Factory is really close to the API or to the microservices. But in the Kubernetes cluster, you could deploy one Trusted Application Factory per namespace, or you could deploy it directly as a big gateway before all the Kubernetes clusters and so on. It's really up to you, and depending also on the typology of your application behind. But yeah, everything could be in Magine, and you could deploy it in line or as a sidecar partner as well.
Okay, thank you. There is no more question. So thank you all for your participation. I hope this webinar has met your expectations. You will receive the link to the video in the afternoon. We have a new webinar on December the 19th, the 9th, which will be a webinar with the company Squad that will speak about the Trusted Application Factory solution they put in place. So we'll see maybe this webinar. Thank you, Edouard. Thank you, Soujanya.
Thank you.
Thank you.
And have a great day, everyone.
Thank you. See you soon.
Thank you for attending.
Bye-bye.